Hi, welcome back. In the last video, I said once we have proved the law of sines derivation, which is a very simple derivation, where we have tried to compare the height from two different angles and find out the law of sines. Okay. Now let's see how we can apply the law of sines to find out the area of the triangle. If you can see here, there is a triangle here, ABC, which is a equilateral triangle. Okay. Now, suppose we don't know the trigonometry, you don't know anything about trigonometry. The only way how you can solve this problem, if you want to find out the area, is half base into height. That is nothing but half into 8. I have to find out this height. For that, I will apply the formula that any line drawn from a vertex to the opposite side, okay, it divides it in the ratio of it divides it uh, the angular bisector divides it in the ratio of the sides of the triangle. So I know this is equal to 4 and this is equal to 4, and based on that I can find out using Pythagoras. I can find out the altitude, and you can simplify it because you know it since long time. It will become nothing but area equal to 16 root 3. It is half base into height. This is half into 8, 4, and this becomes 4 root 3 because you know this is 8 and this is 4. Apply Pythagoras, square root of 64 minus 16, that's nothing but 4 root 3. So the area from whatever we know childhood, half base into height is 16 root 3. Now let us see how we can get it with the help of the trigonometry also. Now what is the formula we have? We have the formula is half AB into sin C. So I can say simply half into area is equal to half A equal to A, 8, and B is equal to 8, and sine of C, A and B. So the angle between them, as I said, law of sines is applicable whenever you have some information out of this 4 variables, right? Whenever you have 3 of them, you can find out the 4. Then you can find out the remaining 2 too, because you know angles of all the triangles together in a triangle is 180 degrees. Now let us see what this gives us. Half into A is nothing but this here 8 into B is nothing but 8, and the angle included between the sides of length A and B is 60 degrees. Sine 60, that's nothing but half into 8 into 8. You know sine 60 degrees is square root of 3 by 2 or radical 3 by 2. This becomes nothing but 64 root 3 by 4. That's nothing but equal to 16 root 3. Right? Now you can see that. Let's take another example and see, because you see here all are 60 degrees. You try to apply this formula, you will see the same thing repeating again and again because it's an equilateral triangle. I just want to simplify the things instead of showing you a complicated version. So always remember that, okay, it's easy with simpler version, right? Now let me take another triangle. I will take another triangle, to be precise a right angle triangle, so that simply we can see how this works out. Okay, let's take a simple right angle triangle. Here we go. Let us say that this is our right angle triangle. Yes, this is the right angle triangle. Let us say that this is A, B and C. You know by now how we denote the lengths of the opposite side. This is small a and this is small b, and this is nothing but equal to small c. I have been given that this length is equal to 8, and also I have been given that this length is equal to 8, and this angle is equal to 45 degrees. Okay, right? That's only the thing I know. I don't know anything else. Let us see how we can leverage and find out the area. Okay, let's see that. Okay, first of all I will apply the sine rule. Sine rule says sine of A by A. This angle I don't know. I will call it as x. This angle I know. I don't know. That's why. Okay. We don't know what is A, so we'll just keep it as A as it is. Now what is sine rule says? Sine of A, that is nothing but I can actually go ahead and say sine of A, or I can say sine of X also. I'll just say A, don't want to confuse you. Sine of A by small a, you don't know what it is, divided by sine of capital B, we don't know what it is, but we know small b is equal to 8. Similarly, we know sine of C, that's equal to 45 degrees, divided by, we know small c is equal to 8. Now if you look here, now if you look at this part, sine of b by 8 equal to sine of 45 by 8, which will give you b equal to 45 degrees. If I know b is equal to 45 degrees, I know that this is nothing but equal to 90 degrees, which gives me angle A is nothing but equal to angle A is nothing but equal to 90 degrees. Okay, right? That's what we have found now. Now let's apply and see whether u area, find out area, it will be equal or not. Let's take the first case of AB into sin C. That's nothing but, we know what's the value of A now? We know what's the value of A? Sin of A, you know that B equal to 45 and C is also equal to 45. So A also will become, what A will become? We'll find it out. Okay, let's do it here. You want to find out A, right? So what is sin of capital A? 90. So say sin of 90 degrees by, what is small a? We don't know, is equal to, let's take sin of b by b. So I say sin of 45 degrees by, I know what is the opposite side, that's nothing but equal to 8. You have to pardon me, this is 8. I mean it. Okay. So this gives me, cross multiply a into 1 by root 2 equal to 8. That means a is nothing but equal to 8 root 2. You can do this, right? Sin 90 is 1, sin 45 is 1 by root 2. So this becomes root 2 here. A equal to 8 root 2. And we also know by Pythagoras, if it's a right angle triangle, you can see here this angle is 90, 8, 8. This becomes 8 root 2. Okay, now let's see how the area looks like. Of into small a you now know it's equal to 8 root 2 into b, small b is equal to b into of AB into sine of capital C, that is nothing but sine of 45 degrees. That's nothing but equal to half into 8 root 2 into 8 into 1 by root 2. Correct? So what's happening now? Root 2 cancels. 2 4 times 4 8s are 32. So the area is 32. If we go to our old traditional method of base into height, this is nothing but equal to half 8 into 8 is nothing but equal to 32. You can also take this as it is and cross check for another angle also. Let's do that. Okay, let's do that. I'll just erase this part and I'll do the second one. Now let's say instead of AB sin C, let us say of BC sin A, and see whether the law, whatever we have found of law of sines, works out properly or not. We are just only trying to understand the concept. Okay, right. Now what is this? Of into B, what is small b? We know small b is nothing but equal to 8 into of B, this is B into C, C is 8. So it's, remember, just whenever you say the area, half into one side of the triangle into adjacent side of the triangle into the sine of angle between them, sine function of angle between them. So what is the angle here between B and C? 90 degrees, right? You know that. So I can say simply half into 64, that's nothing but equal to 32. This is law of sines and useful. whenever you want to calculate the area of the triangle. To summarize, the traditional way of finding out the area of a triangle is half base into height, but it becomes very cumbersome or complex whenever the triangle is not a right angle triangle or the height is not directly given to you. Then you have to go back to the fundamentals of mathematics to say that the angular bisector will divide the base in the ratio of the sides of the other two sides. Then you have to construct a right angle triangle there, find out the altitude, which takes a lot of complicated time. Now we know trigonometry, and we know that trigonometry gives us the leverage to find out the ratio of the triangles by applying the sine, cosine and tan functions on the angles of the right angle triangle. We try to Now we know that the problem we are facing is with respect to the altitude. So what we did, we applied our sine functions on the altitude and tried to compare the altitude by equating it from two opposite angles, equating the value of h, with the help of which we are able to find out the derivation, which says that sine of an a divided by small a equal to sine of capital B by small b equal to sine of capital C by small c, where small c is the length of the side opposite to angle C. Similarly, small b is length of the side opposite to angle B. Now, after we know that this is the law of sine, we went back and tried to find out area of a triangle. We took a case of equilateral triangle and also we took a case of right angle triangle. We know that in a right angle triangle, the area is nothing but equal to half base into height. We know that by traditional method. Now we want to apply the concept of law of sines and see whether it equates to the formula or not, and we generalized the formula that it is nothing but equal to half AB into sine of capital C is equal to half BC into sine of capital A is equal to half CA into sine of capital B. To generalize, area is nothing but equal to half into product of two sides and multiplying with that product of two sides with the sine of the angle between the two sides. We have taken a simple example and we have seen that it's working out well. Okay, that's about the law of sines. In the next video we will see law of cosines, which is also very interesting application of trigonometry. Okay, thank you. Thanks for visiting. Bye for now.